Well, howdy, y'all. Today we're going to be studying the ambiguous case for the law of signs. Well, ambiguous just means that we're not assured of that our answer will be the only answer. So why don't we go ahead and get started with, well, when does the ambiguous case happen? Well, the ambiguous case for the law of signs happens when we're doing, well, the law of signs, and we're given a side, and angle. Well, a side, angle would look something like this. So if we were given the measure of angle A, so if we were given A, we were given the side length of little c, and we were also given the side length of little a, well, these three form a side, angle, or an angle, side. So angle, side, also affectionately known as the Monkey Theorem. I'll let you guys figure that one out on your own. So that's when we have an ambiguous case, or when we could have an ambiguous case. Now let's discuss what can happen. Well, with the what, we have three possibilities. The first possibility is no triangle is created. So given our information, there is no there's no triangle that can be formed. And we'll see an example of that here in a minute. The second, only one unique triangle is created, so only one triangle. And the third, or probably the most interesting, is two non-congruent, so two unique triangles are formed, so two possible triangles. Okay, so two possible triangles. So why don't we go ahead and get started, and I'll show you an example of each. So the first one, we're going to do an example where no triangle is created. Now, guys, there are a couple things that we need to remember, and we'll go over those here shortly. So for example one, if I'm given a triangle with side little a is equal to 7, little c is equal to 16, and the measure of angle A is equal to 30 degrees. Now look at that. That's a nice, pretty thing. Well, first thing I'm going to do is I'm going to draw a triangle. There we go. So we'll label a triangle ABC. And we know that A is 17, C is 16, and the measure of A is 30. So using the law of signs, which I will do in purple, I know that 7 over the sine of 30 is equal to 16 over the sine of C. And solving for the sine of C, we get this to be 16 times the sine of 30 over 7. Now the sine of 30 is just 1/2. That's 8 over 7, which comes out to be 1.428 when I typed it into my calculator. Now I need to figure out when the sine of what angle, so the sine of what angle is equal to 1.428. But you guys are probably going, wait, Mr. N. The sine of any angle only exists in between -1 and 1. It means this is bigger than +1. There's no angle, so no such C exists. So C does not exist. Or the angle C is D and E because sine cannot be bigger than 1. So, not that it's greater than or equal to 1. So, there's no such triangle that will form based on this because you can't take the arc sine. So, the arc sine, which is this, of 1.428 does not exist. You guys will get a domain error in your calculator, and you won't be able to go any further. So this is the first case. This is no triangle exists. So no triangle, no answer. Or I guess that is an answer. It's just not an answer we're used to. Okay, why don't we move on to the second case? The second case we're all familiar with, and this is when we get one answer and only one answer. So example number 2, if I'm given little a is equal to 20, little c is equal to 16, and the measure of angle A, once again, is 30 degrees. We're using 30 degrees because it makes our calculations easy, because the sine of 30 is just 1/2. So once again, we will draw our triangle. We'll label our angles A, B, C. And then we'll label what we're given. So it's 20, 16, and 30. Okay, and now we're going to go back to purple, and we will do the law of sines again. So we know that 20 over the sine of 30 is equal to 16 over the sine of C. And now solving for the sine of C, we get this sine of C is equal to 16 times the sine of 30.
Well, howdy, y'all. They were going to be finding me.
Is equal to 16 times the sine of 30. I'll apologize for that here in a minute. That was me recording another video, and it had just finished compiling. So 16 times the sine of 30 all over 20, which when we type that into our calculator or we do it in our head, we get 0.4. So then we get C, or the measure of angle C. The measure of angle C is equal to the arc sine of 0.4, which is equal to, or which is approximately equal to 24 degrees. I rounded to the nearest degree. Now, so that means that the measure of angle C is 24 degrees. Now I'm going to call to mind again that the sine is positive in both the first and the second quadrant. So if I draw this little guy here, and he has a reference angle of 24 degrees, well, sine is also positive over here with this reference angle of 24. But that measure right here, so from the positive x-axis all the way over there, well, that's 156. So another possible angle would be 156. But 30 plus 156 is 186. And we all know that when we add up all the angles inside of a triangle, they have to add up to 180. So since this is bigger than 180, 156 cannot possibly be a possible angle for this triangle. So we're only left with 1. So 24 degrees is my final answer. Okay, last one. Example number 3. One that we've all been waiting for. Show me where we can get 2 cases. Okay, example number 3. There's my pen. Example number 3. So we're going to say A is equal to 10. B is equal to 16, and the measure of angle C, or angle A, is once again 30 degrees. First step, draw your triangles and label. So A, B, C. As mathematicians, we're really good at doing our alphabet. So measure of angle A is 30, side A is 10, and measure of angle B, or measure of side B is 16. Once again, side angle. Setting up our law of cosines, which we'll stick with the tradition and do it in purple. We get 10 over the sine of 30 is equal to 16 over the sine of angle B. Solving for the sine of angle B, which we crisscross multiply and then divide, we get that it's 16 times the sine of 30 all over 10. Typing that into our calculators, we get 0.8. Now 0.8, so the sine of whose angle, so the sine of B is equal to 0.8. Well, we take the arcsine of both sides and we get B, or the measure of angle B, is equal to the arcsine of 0.8, which my calculator will tell me is approximately equal to 53 degrees. And then we go over, and we're smart kids, so we understand the sine is positive in the first and second quadrant once again, and somewhere up here, this is 53 degrees. And somewhere over here in the second quadrant, E is not a pretty line, but it'll serve its purpose. Its reference angle is 53 degrees. Now, if I subtract 180 from 53, or I take it from the positive x-axis, I get that this guy is 127. Okay, well now, I know that 127, we'll do it in red. So 127 plus 30 is only 157. That leaves a lot of room, and after it leaves 23 degrees for that third angle. So this is smaller than 180, so it can become a triangle. So why don't we go ahead and we'll label our two triangles. So the first one with 53 degrees, we'll do it down here. So we'll label them ABC, ABC. Okay, now in purple, well, we were given that the measure of angle A was 30. And when I solved for the measure of angle B, I got about 53 degrees. And adding those up, and then subtracting from 180, I get the last measure C, would be 97. Now, guys, I hope you realize that I had flip-flopped my B and C, so I'm going to go ahead and change that just to not confuse you, because that would be the worst. So, pardon my mistake, this is angle B, and this is angle C. And when I solved B, I got 53, which would leave C to be 97. Okay, so that was using this guy. There we go, he escaped. And we also knew that A was 10 and B was 16, so A is 10 and B is 16. Now, what about the guy in red? Well, yeah, no upside down triangles. Nope, not today. Now, the other guy, who's a different triangle, even though they look the same in my picture, these aren't drawn to scale, so please be careful with that. Label assigned, A, C. Okay, now we were given A as 30, side B is 16, side C is 10. Okay, but this time, so this time we solved that angle B was 157. This is 157, which would leave C to be 23. And guys, these triangles are not the same. This is why we can't use angle side side as a congruence theorem, because these two triangles are not the same. They are not congruent. That would be the congruent symbol. So these are not congruent triangles. They are two unique triangles, just like each of you is unique. So this would be the third case in which these three pieces of data, so the side angle, yielded two different triangles. Okay, so tomorrow in class we will be doing some more work where we have the possibility of one of these three happening. So just make sure that we remember to draw our little sign up here. This is very important. And I will see you guys in class tomorrow. Have a great evening.